All right, welcome to your extra credit opportunity. We're going to do just a quick overview of polynomials. I know you kind of started this and looked at this a little bit, but this will give you an opportunity to earn a little bit of extra credit in the process, and also learn about some of the vocabulary words we're going to be using pretty extensively for the rest of the year, especially since they are so important to understanding what you're supposed to be doing as you're working through the math. So your essential question is, why are all the vocabulary words in this lesson so important? And this would be a good point to pause until you get that copy down, then restart. Remember, as you go through this, you do need to take these in the Cornell note style. You'll lose points if you're not, if the whole set of the entire set of notes are not in the Cornell note style. The vocabulary words that we're going to really look at today through this lesson and this extra credit lesson. And notice it says be sure to define the following words. I'm giving you the words, and some of them will define together, some of them we may not, so you may have to go back and look through your lessons, especially the 3.01 lesson, and find the definitions for these words and add them to your notes, which is important too, because that's part of what you're supposed to be doing for your Cornell notes, is adding things to the notes after the lesson's done, and you do it in a different color. And some of you may be doing that already, but you're forgetting to do it in a different color, or do something to let me know that you've actually added things to the notes beyond what was in the lesson. So as you might want to pause here to get those copied down so you make sure you have all of them. So the first question here is, what is a monomial? That's one of your vocabulary words. So hopefully you maybe left some space between the words so you can write things down. Otherwise you may have to start below the list and then maybe just check off the list as you get these down. A monomial can be a number, just like the number 6. That could be a monomial. A monomial can also be a variable with a whole number exponent. So that could be something like x to the 4th. The 4 is a whole number exponent, and x is the variable. Another example of a monomial, it could be a product of a number and one or more variables with whole numbered exponents. So an example of that could be, let's say, 3x to the 4th, y to the 5th, z, and z would be to the first power since there's no exponent. So you can see that it says a product. That means I'm multiplying everything. 3 times x to the 4th times y to the 5th times z. And so you have a number like 3 and one or more variables. So there's actually 3 variables in this example. And all 3 of them have whole number exponents. X has the exponent of 4, y has the exponent of 5, z has the exponent of 1. If you're not sure what whole number means, I would suggest you look that up and write that definition down as well, so you understand exactly what this definition is telling us. So here's some examples. I put some examples there, but here's some more examples. This first example right here falls into this category here. Here we have a -1, because if there's no number there, it's always a 1. So you can put a little 1 there. Maybe a different color so you can see it better. So it's like a -1 here. Times y times z. That's like the third part of this right here. So it says a product. It also shows the 6 like I had above. You have a number times a variable with an exponent. That goes with this piece right here. Here's a number, negative 34, times variables with exponents, and there's several of them this time. And then there's this one right here, and that is a monomial. But let's see why that's a monomial. D over 6 is the same as D divided by 6, but it can also be written as 1/6 times D. And since it's D over 1, if we think about it in terms of multiplication rules, then the D would end up on top if we actually multiplied it out. So our number, so we're actually looking at this third example here that describes what a monomial is, because we have our number 1/6 times our variable with the whole number of exponent, and the exponent on the D is a 1. It's important to be able to look at it this way or this way as we go through our work. The thing that all these have in common that you need to notice, however, is this word right here that says product. So the product. All of these things are either just a single number like the 6, or they're products. They're items that are being multiplied together to create a single number. Okay. The other thing is that these all are also called terms, and we're going to see that in a second. Right now, by themselves, standing alone, they're monomials. But eventually, these particular things are going to be called terms. We're going to see when that happens in a couple minutes. All right. So what is a coefficient? And it says a coefficient is a numerical factor. And that goes back to what we just talked about. Remember, we have the example back here of 3c to the 4th. I'm going to go back. I'm going to write that down here. 3c to the 4th. Okay? This is a numerical factor. That means a factor that's a number. Because this is 3 times c to the 4th. Just remember what a factor is. Again, you may want to write this down and look that up as well if you're not sure what a factor is. The factor is the numbers that are multiplied together to give you a solution when you're doing a multiplication problem. So like if I say the factors of 12, that would mean 3 could be 3 times 4. 3 and 4 would be factors because 3 times 4 makes 12. Or it could have been 2 times 6. 2 and 6 could have been factors because 2 times 6 makes 12. So in this case, we've got different factors here because we've got two numbers being multiplied together. So one factor is 3. The other factor is c to the 4th. So we want the numerical factor. So that means we're talking about the number 3, that number that's with the variable. So it's asking here, what are the coefficients of the following expressions? I happen to actually write down the same expressions that we had in the previous slide. So as we're looking at this, the coefficients, for some of these are pretty obvious. We already know about the 3. That's a coefficient because it's the number that's being multiplied times the variable. Here we've got a negative 34. And this one we kind of talked about. Remember, that's the same as 1/6 times d. And if we see it that way and look at it that way, then we can see that our coefficient is 1/6. Now, here's the tricky part. Let's go back to these other numbers. So there's some that look like they don't have a coefficient. But remember, if there's no number there, the number is always 1. So it's 1 times x to the 5th. And remember, as we said, there was a negative 1 here, even though it's not, the 1's not showing. And if that's the case, then our coefficient here is 1, and our coefficient here is negative 1. But what about this situation right here? Well, that is not a coefficient because there's no variable with it. So this is an example where it's not a coefficient because remember we said it's a numerical factor, and that numerical factor is going to be with a variable. So that is not a coefficient. we're going to call it something else, and we'll find out what that something else is in a little bit. Actually, I'm going to tell you what it is right now. It's going to be called a constant. But we'll talk about that a little bit more. Okay. So what is meant by degree? We're going to use the word degree, and you're going to see the word degree in directions and things like that. So as we look at this, the word degree, it means the sum of exponents of the variables in an expression. So let's take a peek at what that really means. And by looking at and asking yourself, what is the degree of the following expressions? So again, we're going to use the same ones we just did, and we're going to look at the degree of the expression, variable expression. In this case, there's an exponent here of 5, and there's no other variables, no other exponents, so the degree on this is 5. For the next one, we have a degree of 1, or an exponent of 1 and an exponent of 1. When there's no number there, remember it's a 1. So my degree would be 1 plus 1, which gives a degree of 2. Now, I'm going to skip this one. We'll come back to it. Let's go to the next one. The degree on my variable here, I only have one variable, and it has to the 4th power, so my degree here is 4. But let's look at this one right here, the next one, because I have a to the 5th, b to the 3rd, c to the 8th, and if there's no variable, it's always a 1. You can just write it right in there if you need to. So I need to look at that. And so the degree of this is the sum of its exponents. That means I have to add all the exponents together. So a 5 plus the 3 and is 8, plus an 8 is 16, plus 1 is 17. So my degree here is 17. Again, remembering this, the way to think about this is 1/6 times d. d has an exponent of 1. So my degree here is going to be 1 because there's no other variables with exponents to add to that. And the final one is the one I skipped earlier, and that's this one. And since there are no exponents there, or no variables with exponents, then the degree would be 0. And that makes sense because anything to the 0 power, remember, makes 1. And you could say 1 times the 6 is still 6. So the exponent would have a degree of 0 if there was an exponent there. But we can also think of it as there's no degree, there's no exponent there, so the degree is 0. All right? So what is a polynomial? A polynomial is a monomial or a sum or difference of monomials. So a monomial is a polynomial, but a polynomial can also be a sum or difference of those monomials. So here's some examples. Here's the first example. So we could have the monomial 3x squared, and that's also called a polynomial. It's just that there's only one, what we call one term to that. And if you think of the word mono, mono means 1. Okay? And we'll talk a little bit more about that in a little bit. So there's one term there. But then we have this other one where we have, if you we're ignoring the additions of the parts after the addition and subtraction sign, you have, this would be, if it was by itself, that would be a monomial. If this was by itself without the other stuff, that would be a monomial. If that was by itself without the other addition and subtraction stuff, that would be a monomial. And that would also be a monomial. Now, as we're looking at this, we have a whole bunch of monomials that are being either added, sum, or subtracted, difference. And so we've got the monomial added to another monomial, which subtracts that monomial, which subtracts that monomial. So together with the addition and subtraction signs, it makes a polynomial. And that polynomial has 1 2, 3, 4 terms to it. Okay, because there are 4 of those monomial pieces together. So when you start putting those monomials together and adding and subtracting, then we call another name for those, because they can't be monomials anymore because they're not standing by themselves, so we call them terms. So there's a term, there's a term, there's a term, and there's a term. Now, one of the things we need to keep in mind as we're doing this, when we're working with these pieces, is that usually sometimes we start mixing reordering the terms, and so we always want to keep the sign that's right in front of it with there. So we could think of that as a positive 3b squared. We could think of this as a negative a cubed b cubed, because another way to write subtraction, remember, is plus a negative, and we can think of this as a negative 8. We don't want to always rewrite it every time, so we can just look at that. If we kind of know this other part where it's plus and negative, we can just think of that subtraction sign as a negative and move it with pieces as we move things. Okay, so let's look at another example. This one's a little simpler. So we've got, again, 2 monomials that are being put together with a subtraction sign. So that's called a polynomial. And so we have 2 terms there. And we can think of that as a positive 9. And you can think of this as a negative x. Although I know it does say subtract x. If we have to move it around and rewrite it, then we would say negative x plus 9, and that would mean the same thing as what's written right now. Okay. Again, if you need to pause, I'm not reminding you to pause after each one, but if you need to pause, go ahead and pause it and write down what you need to write down. If you need to review things, go ahead and review things, and then move forward at your pace. Okay, so what is the degree of a polynomial? Well, and that's important for us to understand, because it helps us put the numbers in order, in a specific order, and be all consistent as we all work together. But the degree of a polynomial is the degree of the monomial, or the term, with the greatest degree. So let's look at what that means in terms of our numbers and that kind of stuff. So I put an example of opportunity on here. So the first thing I have to do is I have to find the greatest degree. So I'm going to look at each term. So here's a term right here. Here's a term right here. Here's a term right here. Notice I can put the negative sign in, the subtraction sign in there, negative sign in there. And there's a term. Okay, so we've got 4 terms. If we didn't have the add or subtract, they were standing by themselves, they'd be called monomials. Because they're in the add or subtract piece, we're going to call them terms. Now we have to figure out the degree of each of those. So the degree of this first one, remember, there's no exponent, it's always a 1. And so I have to add the 1 plus the 5, so I have degree 6 here. The next one has degree 2, because there's only a 2, there's no other variables to add to that, with the exponents to add to that. The next one has a variables with exponents of 3 and 2. So if I add those together, it would be 5. And the last one would have a degree 0 because there isn't a variable there. So if I rewrite that, then I'm going to have the one with the highest degree first. Okay, so that would be, this one would go first. There's the next highest degree, so this one would go second. This one would be third, and this one would be last. So let's just rewrite that together to make sure we're understanding what that means. For those of you who need to see it, so I've got 4ab to the 5th would be the first one because it has the highest degree. And then I would say minus a to the 3rd b to the 2nd because it has the next highest degree. Then we would say plus 3b squared because that's the next one, and then minus 8. And that would be kind of what we consider to be a standard form of the polynomial. We go from the highest degree to lowest degree. Now, if the number of degrees is tied, we start with first variable, like if we had, let's say, a to the third, b squared, and then a squared, b to the third, then we would look at the very first, we'd make sure everything's in alphabetical order and look at the very first variable in that, and then look at the next variable and so on, and put them in numerical order. So this one would come before this one. Okay? So I kind of got ahead of myself with the slides. This is what standard form. And standard form of a polynomial is when the terms are arranged in decreasing order of degree. Now typically we won't see this at this point in time, the expression polynomials are as complex as the ones we just looked at, but it's still important to understand what's happening with that. So let's look at an example, and we're going to put this in order in standard form. This is more typical of what you're going to see. So we need to take a peek at our exponents. This one has 4, has a degree of 4. This one has a degree of 0. This one has a degree of 8. This one has a degree, actually it's supposed to be an x. I'm sorry about that. It should be x. So that would be a degree of 1. And this one would have a degree of 6. So if I'm going to put this in order in standard form, I've got to start with the one with the highest degree, which would be this one right here. And so I need to bring the negative sign along with it. So it's negative 3x to the 8th. The next one after that, and I can cross it off if I want to, next after that is this one. So it's plus 7x to the 6th. And after, I'm going to cross that off because I used it. Then after that is x to the 4th, and it's a positive x to the 4th because if there's no sign it means positive. And then after that we go to our 12x, so it's minus 12x, and then plus 6. And now it's in standard form because our degrees of our polynomial are going from increasing to decreasing. So let's practice that a little bit. It says write this particular polynomial in standard form. So again, we're going to look for the highest degree, and that happens to be 3n to the 4th. So I'm going to write that first. And then the next one after that is 4n to the 3rd, and it's a positive 4n to the 3rd. After that, I'm going to go to the say negative 5n or subtract 5n. And after that, I'll do the plus 8. Now it's in standard form, going from highest exponent to least, or highest degree to least highest degree. Highest to least in terms of degrees. So now it's asking what's the degree of the polynomial. So going back to what we talked about, where the degree of the polynomial is the degree of the term with the highest degree. So the highest degree in this case is 4, because our term that has that's the highest degree of each of those terms. So the answer here would be just 4, because we're looking at this particular one right here. Now it asks, what's the leading term? Okay, well, we have to, first of all, in order to find the leading term, we have to put our polynomial in standard form, because we want to make sure that we have our term with the highest degree first. And because our leading term is the term with the highest degree, and it's going to be placed first in standard form. So for our situation here, in the problem that we have, if we're looking at this, then this is our term with the highest degree, and it's placed first in the standard form. So our leading term would be 3n to the 4th. And then as I look at the next step here, it's asking what is the leading coefficient. Well, if you're thinking about leading coefficient, it makes sense that it's going to be the coefficient of the leading term. So if I'm looking at that, then if if I'm looking at the leading term, which again is right here, I can look at it down below where we wrote it. We're going to look at the coefficient, which is just the number part, the number that's being multiplied by the variable. So the leading coefficient here is a 3. Okay. So again, if you need to pause as I'm going through this, pause whenever you need and then start. All right. So monomial has one term. So we're going to classify polynomials, and we started talking about monomials, and I remember I mentioned it has one term. We give an example here. And everything in there is being multiplied. A binomial has two terms. So, for example, I started with the monomial I had before, but now I'm going to add or subtract another monomial. So we have two terms, 4x y squared and then 2x to the cube yz. I know that this is a term because the numbers are being multiplied together, and this is a term because the numbers are being multiplied together, and they're separated by an add or subtract sign. So a binomial has two terms, which makes sense because we know that the word bi means 2, and mono up here means 1. So that makes sense that if I say binomial, it's going to have two terms, and it's going to look something like what I just did. And so I think if you stop and think about what might come next, you're going to guess that maybe it might be a trinomial, and you would be correct. Okay? A trinomial has three terms. Again, it makes sense because tri means 3. So again, an example, here's our first term, everything's multiplied there. Here's our second term, everything's multiplied there. Here's our third term, all multiplied and connected with addition or subtraction signs. So we know they're polynomials because they have addition and subtraction signs. So when you talk about polynomials, we can give different polynomials different names, just like when we talk about shapes. We give different, when we talk about polygons, those polygons have different names, like triangle, because it's tri, it means 3 sides and 3 angles. Or we talk about quadrilaterals because it has 4 sides and 4 angles in terms of polygons, or a pentagon because it has 5 sides and 5 angles. Same thing happens with polynomials. Except we classify them using those same kinds of terms. We just say monomial, binomial, trinomial, and it tells us something about the polynomial. Now, we can classify polynomials by the number of terms, which we just did, or by its degree, which we're doing by putting them in order for standard form. We can do it by both. And when we start putting them together and looking at both of them at the same time, we write the name of the polynomial first, the kind of polynomial. So what we're going to do is if it has degree 0, remember I said if it's just a regular number like this, it's a constant. Okay? And it made sense that it was degree 0 because if we multiplied 6 times like x to the 0 power, if the exponent was 0 power, then that would make 1. Okay? So we are going to use this word constant quite a bit when we talked about the equation of a line, like 3x plus 4. We talked about that 4 being a constant, and this 3 was the coefficient of the x. And so that's because of the degrees, because that would be to the first power, and this would be times x to the 0 power. So we don't need that. I'm going to cross it off. We don't need it because it's times 1. Oops. So it should be 3x to the first plus 4, or just 3x plus 4. So this is kind of tying back into some things we've talked about before. If we have something like 3h plus 4, very similar to what I just wrote. Then the degree is 1. We looked at that. The highest degree in this is 1. Remember the one over here that I crossed off was 0, and we had one with a degree of 1. If the highest degree is 1, you know you're going to have a line when you graph it, so we call it a linear equation because we know it's going to make a line when we graph it. And the example of that is like this, where the highest exponent here is a 1, and the 1 doesn't show because we don't usually write the 1 there. We just assume it's there. All right, the next one, and this is what we're going to start working with through this lesson, or through this unit, and for the next couple units actually, is when we have a degree of 2. And it gives you an example here. The highest degree is 2, and when that's the highest degree, its classification is what we call quadratic. Now I know it has the word quad in there, and you know, well, that's 4, and why is that the case? Why is it has a degree 2? Why is it the case? Well, we're going to kind of discover that a little bit later, so I'm not going to go into that right now, but this is called a quadratic equation, or a quadratic expression in this case because there's no equal sign. And the highest exponent it has a 2. You're probably going to have a constant in it, but you don't have to, and you're probably going to have a term that has an exponent of 1, but you don't have to. It could just be c squared. Okay, and this is going to, when you graph this is going to have its own special shape. This one right here is just a point. This right here is a line, and this one has its own special shape. Just like we found out that absolute value things have their own special shape. Okay, let's look at the next one. So if we have a highest degree 3, which means in this case the exponent here is to the 3rd power, that's called a cubic like that. And the last one is a quartic. So when it has the highest degree is 4, it's called a quartic. Now, we don't just use that classification term. We also have a little bit more that we can tell about each of these. So see, the example that's given there is a constant, and it's going to pretty much always be a constant, and it's also known as a monomial. It's one way to think about it. There are other versions of monomials, but this is another way to think about it. Linear, because it's got 2 terms. If I look at this, I've got 2 terms. This would be called a linear, and we can use the terms from the last page up here. We were talking about monomial, binomial, trinomial. It's got 2 parts, so this would be a linear binomial. Because it has 2 parts, but it also makes a straight line when we graph it because its highest degree is 1. This is a quadratic trinomial because you can count the parts. And you can see there's 1 term, 2 terms, 3 terms, so it's a trinomial. For a cubic, in this case there's only 2 terms, so this would be a cubic binomial. And because there's only 2 terms here, 1, 2. And the quartic would be a trinomial because there's 3 terms. And sometimes we will say quartic trinomial because we could have a quartic binomial, and that helps us distinguish between those things. All right, so let's practice this a little bit, and this will be our last thing that we're working on today for your extra credit notes. So here's our polygon, our polynomial. I'm sorry, I used that word earlier and it's stuck in my head. So here's our polynomial, and it's asking us to put it in standard form. So for doing that, this is the highest degree, so I'm going to have 5x to the 3rd. This is the next highest one, so I'm going to put negative or subtract 3x squared. And this is the last one. All right. So let's see what comes next. Now it wants the degree. So the highest degree on this happens to be this one right here. So the highest degree is 3. And that highest degree of 3 tells me something. We're also looking at the number of terms. How many terms do we have? And we look and we count that, and we can see there's 3 terms, which tells me it's a trinomial. This degree of 3, it also, because of the way it's written, it also tells me this is a cubic polynomial, which tells me that my graph, it tells me something about the graph that I'm going to be graphing if I do a cubic graph of that. So if I'm going to classify it, the whole thing, I would write cubic trinomial. Okay, with that, I would make sure you do a quick summary and answer your essential question. If you need to go back and fill in some holes, go back and do that. But with that, we are done for the day. Thank you very much.